Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we will explain the characteristic of the PN-junction diode. We will do the experiment in the analog lab. Let's begin with the theory section. Of course, the PN-junction diode is constructed with semiconductor material. As we know that there are two kinds of semiconductor, which are germanium and silicon.
There are two connections of PN-junction diode, forward bias and reverse bias. The silicon diode has a depletion layer between positive and negative side. In the forward bias, the current will not pass until the voltage reaches 0.7 volt through the diode, because it's the barrier potential of the silicon diode.
In this experiment, we will need these equipments: a DC power supply and two digital multimeters and wires for the digital multimeter, wires for the DC power supply, and a small wire and a resistor, and of course we need a silicon diode and this board. I want to explain about how can you know the forward bias and the reverse bias through the diode. Of course, I don't know if it is clear for you, but there is a gray line. There is a gray line in here. This is the negative side and this is the positive side. As you see, if you can see it, the gray line, this is the positive and this is the negative. If you want a forward bias, you should connect the positive side with the positive polarity from the DC power supply, and this side with the negative polarity from the DC power supply. Of course, if you want a reverse bias, you only have to reverse the diode. You will make the positive, the negative side, the negative side connected with the positive polarity from the DC power supply, and the positive side with the negative polarity from the DC power supply. I don't know if you can see the gray line at the end of the negative side. This is the gray line here. We have to turn on the DC power supply. Of course, these are the polarities of the DC power supply. This is the positive and this is the negative. We will construct the circuit as you see. This is the resistor series with the positive polarity, and these are for the ammeter. This is the ammeter here, milliamp, and it connects between the resistor and the silicon diode. Of course, this is the silicon diode. It is in forward bias and it connects between the resistor and the negative polarity of the DC power supply. Of course, we will put the voltage meter parallel with the diode so that we can know the voltage of the voltage through the diode. Of course, here is the voltage meter. We will see the voltage. Firstly, we will increase it a little bit. The current will be approximately 0, and as we know, it will not pass any current until it reaches 0.7 volt or maybe 0.6. Here 0.3 volt. It will not pass any currents. If we reach it, if we increase it a little bit until it reach 0.4, the current will start to increase a little bit, just small increasing. We'll increase it to 0.5. As you see, there is slight increase in the current. It is considered as nothing. But if we increase the voltage to 0.6, the current will start to increase slightly. Here are 0.6. The current will pass to 1.9. It is 1.9. It's 1.2. If we increase it to 0.7, it will increase the current. The current will increase. There is a rapid increase in the current, as you see. It is 0.7. The voltage is 0.7. It is 0.7, and the current is 10.2 milliamp. Of course, as I told you, the current will not pass through until it reaches the barrier potential, which is 0.7 in the silicon diode. About the germanium diode, the barrier potential is about 0.3. Of course, we will now reverse the diode. You only have to change the direction of the diode. You will have to make it the back way. Just take it and reverse the direction. In this circuit, we reverse the diode, the silicon diode, we reverse it. So this is the connection for a reverse bias. As you see, the voltmeter is 0, and the ammeter is 0. It's the it's in the milliamp. Of course, the silicon diode and reverse bias acts like an open switch. It will not pass any current through it. So now we will increase the voltage from the DC power supply, and we will watch it from the voltmeter. As you see, we will start to increase it. It's now about 2 volt. 2 volt, and the current is 0 amp, 0 milliamp. And if we increase it more, let's make it 10. This is 10 volt, and the current is still 0. And if we increase it to 20, the current will still at 0. Even if we raise it to its maximum, because this power supply only can handle 30 volt, it will be 0. Of course, there is a breakdown region for the silicon diode, the PN-junction silicon diode. If the diode reach this region, it will damage. It will break down and damage.
I hope that the experiment was clear to understand. Thank you for watching us.